Ayan. Okay, so let's start our discussion. Okay, so the first topic for the laboratory part of this semester would be on the solutions. No? Okay, so during your inorganic organic chemistry subject, no, you know that uh, solutions are made when you mix two or more substances and the appearance is homogeneous, di ba? 'Di ba, yung matter, kina-classify natin yon, pure substance or mixture. Nasa mixture yung solution, 'di ba? So kapag homogeneous mixture yan, it is a solution. Okay? So ang i-discuss natin ngayon ay ano yung qualitative aspects ng solution. So ano yung mga qualities of solution, paano siya nabubuo, what are electrolytes, no? How to determine if a substance is an electrolyte or not, no? And then we will uh, proceed with the concentration units, no? This is the qualitative aspect of this chapter, no? Ito yung qualitative, no? Quali yan. And then the remaining last part would be the quantitative aspect, no? So ganun yung anachem natin parate. May qualitative aspect, then may quantitative aspect siya. Okay? So let's begin with the types of solution. Okay? So again, as I told you last time, and even last semester pa, no, your instructor told you that a solution is a homogeneous mixture, no, of two or more substances. No? When you say homogeneous, that means the final appearance should be the same all throughout. No? So, hindi pwedeng may layers, no? Because if yan ay may layers, hindi yan homogeneous mixture. Therefore, it is not a solution. Okay? So, our solutions can be made by mixing two or more substances, no? And then, depending on the amounts of those substances, we can classify them as solutes or solvent, no? When we say solute, these are the components of the solution that happens to be present in small amounts, no, or in smaller quantities. Okay? So yun yung solutes, no. So again, when you say solutes, we are pertaining to the components of the solution that are present in small amounts, no? And then the remaining part, yung solvent, ito naman yung component ng solution that is present in huge quantities. No? Or for example, iced tea. Okay, kunwari nag-lunch kayo, nag-iced tea kayo. Yung iced tea, that is a solution. Okay, so ano yung components ng iced tea? Of course, meron yung water. Okay, so let's say 2 liters of water or 1 liter of water, di ba? And then, ano gagawin mo sa water? Maglalagay ka ng iced tea powder, 'di ba? At least isang sachet 'yon. So, let's say around 10 grams, 20 grams of that. Okay? So, uh, since mas onte yung powder na 'yon compared to the water, then we say that yung powder ay yung solute, no? And then yung water ay yung solvent, no? And then by mixing them, you prepare your solution na, no? So, ganun yung solution. Okay? So, again, dalawang components ang solution. Solute, yun yung onti yung amounts ng matter. Solvent, yun yung marami in terms of the quantity. However, in chemistry, kapag sinabing solvent, usually we are pertaining to water because water is the universal solvent sa science, no? So, kapag sinabi natin solvent dito, most of the time we are pertaining to the water. Okay? So, ganun. So, depending on the components of your substances, yung solution natin, they could have different appearances, no? So, ang common sa analytical chemistry ay liquid solutions, no? However, there are also other types of solutions. For example, the gas in the air, no? Yung ating hangin sa paligid, the atmospheric air, the atmospheric gas, no? ay composed yan of different molecules. No? For example, nitrogen, oxygen, methane, carbon dioxide. No? So lahat ng yon halo-halo and yung overall appearance nila ay gaseous phase. No? So solution yung hangin. No? Tapos yung liquid, yun yung common. And then may solution din na solids. No? For example, yung mga metals, no? Yung solder, yung ginagamit sa hinang. No? So yun yung mga types ng solution. For analytical chemistry, we will be dealing with liquid solutions lang. Okay? So hindi na natin papakilaman yung gas solutions and solid solutions. So focus tayo on the liquids, no? Okay. So yun lang. Okay? So depending also on the amounts of your solute sa inyong solution, we can classify our solutions as follows, no? Pwedeng saturated solution yan, unsaturated, and supersaturated solution. Okay? So tignan natin yung difference ng tatlo. Okay? From the word itself muna, kapag sinabing unsaturated, that means the amount of solute, no, that is present in your solution is less than the capacity of the solution, no, to dissolve. Okay? So ang bawat solvent kasi may kanya-kanya siyang capacity, no, kung hanggang saan or kung hanggang gaano karami yung solute na kaya niya tunawin. Okay? So, kapag onti lang yung solute na nilagay mo sa solution mo, you have unsaturated solution. Okay? Pero by the time na ma-reach mo yung maximum amount na kaya niya tunawin, pag na-reach mo yung maximum amount na yon, you have your saturated solution. Okay? Then, kapag nasobrahan mo pa yun ng solutes, yun na yung super saturated. Okay? So, i-ano natin, i-visualize natin yan, let's say sa asukal at sa tubig, di ba? Kunwari, buko juice. Okay? Kapag naglagay kayo ng onting asukal, what happens? Matabang siya. So, ibig sabihin, unsaturated yon. Kapag naglagay kayo ng exact amount ng sugar na kaya tunawin ng water, yun yung saturated. Kumbaga, yun na yung masarap. Okay? Pero wala pa siyang crystals na nabubuo. However, once na sumobra yung yung dami ng asukal na nilagay mo, pag sobra-sobra na talaga, yun yung super duper tamis na, no? So super saturated na yon. Tapos, ano pa mangyayari? There are crystals of the sugar that are present in your solution. Okay? So ganun po, no? So let's look at our virtual laboratory here. Ma-explore natin sila lahat, no? So we have excuse me. So we have here this solution. Our solute will be copper 2 sulfate, no? So ito, wala pa tong solute. So kumbaga ito ay pure substance pa lang. Water lang to, no? So lagyan natin ng onting solute. Okay. So may onting solute tayo. So meaning ito ay unsaturated, no? However, if we continue to add our solute, we will reach the point of saturation. Ibig sabihin, nandun na siya sa maximum limit niya, no? And then, kapag nagdagdag pa tayo ng mas maraming solute, ano mapapansin nyo sa ilalim? Nagkakaroon na tayo ng crystals sa ilalim, no? So, ganun yung ginagawa ng iba, no? Para mag-create ng crystals from salts, no? So, ginagawa nila, reset natin, ginagawa nila, they just make super saturated solutions. Okay? So, yan, nasa saturated point na tayo. Then, ginagawa nila, gagawa sila ng super saturated solution and then they will wait until those crystals form solid chunks, no? Ayun yung mga binibentang crystal, no, sa Facebook. So, ganun lang yung ginagawa. Okay, you can also do this in your homes, no? Gawin nyo, kuha kayo asin. Eto, asin. So, buhusan nyo lang yan ng yung tubig, buhusan nyo ng asin until ma-reach nyo yung super saturated point, no? Tagal naman pala na ito. Ayan. Tapos pag na-reach na yung super saturated point, ilagay nyo sa freezer para itong mga crystals mamuo, no? So yan, magiging solid yung chunk na yan, no, ng asin. Okay? So yan. Tapos pwede nyo siya gawing pendants or display sa bahay. Parang mga Himalayan salts, ganun din yun. Okay, so that's how you prepare crystals then. Okay, so ganun lang. So depending on the quantity of your solutes sa inyong solution, you can have unsaturated, saturated, and supersaturated solutions. Ano yung difference? Pag unsaturated, less than the maximum amount yung solute mo. Kapag saturated, maximum amount na yung nilagay mo. Pag supersaturated, over the maximum amount na yung solute sa solution mo. Okay? And then, it will start to crystallize na. No? Okay? So, yan. And let's talk about how solutions are made. No? Paano ba nagkakaroon ng solution? No? So, there are three processes that we have to consider when preparing solutions. No? So, the following are solvent-solvent interaction, solute-solute interaction, and then solvent-solute interaction. So depending on the intermolecular forces of our solvent, solute, and the solvent-solute, no? Depende sa kanilang intermolecular forces, we can predict whether a solution will be made or not, no? Okay? So, usapang compatibility kasi tayo dyan, no? Okay, so for example, ah, ang ating solute at yung solvent, parehas sila ng intermolecular force. What will happen? They will mix, no, to form the solution. Okay? Because if they do not have the same intermolecular forces, then magsiseparate yan. Now, let's have for example yung mantika pati tubig. Okay, what happens when you mix them? Okay, so when you mix oil and water, they separate into layers. So hindi ka makakagawa ng solution doon, no? So ano mangyayari, no? Kasi ang water, ano nangyari? Yung water kasi, yun ay dipole molecule and it can perform hydrogen bonding, 'di ba? Yung mantika, ano yun? Non-polar molecule yun that is just composed of hydrocarbon chain, no? Yung mantika natin, ganun lang yon. So, hindi talaga sila maghahalo. You are mixing dipole with London dispersion forces. Hindi match yun, no? So, hindi sila maghahalo. Therefore, a solution will not be created, no? So, ano pa ibang example? Let's say, asukal, pati tubig. Okay. 'Di ba nagbe-mix naman sila. Bakit? Because yung ating sugar, it can perform hydrogen bonding. 'Di ba may mga OH yung sugar. Kung naaalala nyo, kung hindi nyo na pala naaalala, ito yung ating sugars. Excuse me. So yung mga OH yan eh, 'di ba? CH2OH. Ayan, may mga OH yung sugar natin and then yung water. So, yung mga OH na yon, it can perform hydrogen bonding with water. So, yung sugar natin, magmi-mix talaga yan with water, no? However, may limit, no? Kasi magki-crystallize na yun kapag sumobra na. Okay? So, ano pa example ng makakagawa ka ng solution? Let's say, asin. Na+, Cl-. Di ba kapag yung asin na tunaw, nagiging ions yan. Okay. So, ito yung ating water. Okay? So, paano magmi-mix yung asin, pati yung water? Paano nagmi-mix yung ionic compound with water? Remember that water is a dipole molecule. So, that means it has a partial negative end. Zoom natin. So, may partial negative end yan and may partial positive end yan. Okay? So, the partial negative end of water will be attracted to the cation. Okay? So, mag-a-attract sila. Okay? So, ibig sabihin, may interaction sila. May solute-solvent interaction. So, ganun din yung anion. The negative charge of your anion will be attracted towards the partial positive end of water. That's why favorable na mga form ng solution with ionic compounds. No? Yung ions kasi ang dahilan bakit sila humahalo sa tubig. Okay? So, pero again, may limit din yan, no? Kasi mag-crystallize yan kapag sumobra na. Okay? So, yun yung mga kailangan natin i-consider when we are preparing solutions, no? So, depending on the intermolecular forces of attraction, we can have a solution or not, no? So, if you want non-polar solution, that means you should have non-polar solute and non-polar solvent. No? For example, carbon tetrachloride in benzene. Okay? So, carbon tetrachloride is non-polar. Ano itsura niyan? Ito yan. The dipole moments will cancel out. So, this is non-polar. Ano itsura ng C6H6? Yun yung benzene. Non-polar yan, di ba? Discuss yan last sem. Okay? So, this is non-polar, this is non-polar, therefore, they will mix, no? So, ganun. Nasa compatibility lang talaga yung issue. Okay? Ano pa? Yung polar sa polar. Let's say, alcohol, no? Ethanol and water. So, ito yung alcohol, ito yung water. Okay? So, ano yung pwedeng interaction nila? Pwedeng dipole-dipole and hydrogen bonding. Okay? So, ito yung hydrogen bonding na pwede sila mag-interact dyan. Okay? So, yun. And then, yung example natin kanina, yung salts, no? Yung ionic compounds with water, no? So, yan. So, paano sila mag-interact? Ion dipole interaction, yan. So, ion dipole. Okay? So, ito yung ion, ito yung dipole. Ion dipole interaction. Paano naging possible yan? Because of the partial charges. No? Okay? So, yung positive attracted sa partial negative, yung negative attracted sa partial positive. So, that's ion dipole interaction. Okay? So, ganun lang. So, you should check, no? Pag may London dispersion forces dyan, dapat ang kasama niya, London dispersion forces din. Okay? Pero kapag yan ay dipole or ionic o kaya hydrogen bond, kailangan yung kasama niya ay isa sa mga yon. Okay? So, you can prepare your solution there. Okay? So, ganun lang. Ano kasi mangyayari kapag hindi sila matchy-matchy? Ang mangyayari ay they will not mix thoroughly. No? So, magsiseparate sila into layers. Okay? And also, depending on the qualities of your solute, no, you can have an electrolyte or a non-electrolyte solution. Okay? So, ano yung difference? No? Pag sinabi nating electrolyte solution, that means that your solution is composed of ions. No? So, that means you can prepare an electrolyte solution out of ionic compounds. Okay? So, kailangan may ionic compound ka para ikaw ay may electrolyte solution. Kapag non-electrolyte solution yan, that means hindi dapat ionic compound, molecular compound na. Okay? And then yung electrolyte solution, we can classify that into two. Pwedeng weak electrolyte, pwedeng strong electrolyte. No? So, ano yung subtle difference? No? Kapag strong electrolyte, we are talking about ionic compounds that fully dissociate. No? Ionic compounds that fully dissociates. Okay? So, ano yung mga ionic compound that dissociates completely? E di yung mga metal plus non-metal. So, sila yung usual na ionic compounds that dissociates fully. No? So, naghihiwalay talaga yung ions nila. No? Although, malalaman natin later on sa anachem na hindi ganun yung case. No? Pero sa ngayon, tanggapin muna natin. Susunod pang chapter yun eh. Okay? So, yun yung mga ionic compounds that can form strong electrolyte solutions. Yung ionic compounds na magdi-dissociate agad, no? Okay? So, usually sila yung mga metal, non-metal compounds, no? Yung mga weak electrolytes naman, ito yung ionic compounds, no? Ay sila yung ionic compounds that do not fully dissociate. That do not fully dissociate. An example niyan, yung mga organic acids. For example, suka, ayan. Organic acids or bases, yan. So, yan yung mga example ng weak electrolyte. Okay? Yung mga non-electrolyte, edi of course, hindi ionic compound yan. Okay? Mga molecular compound yan, such as alcohol, no? So, yan. Okay, so again, to sum up, no, kapag sinabing strong electrolyte, we are pertaining to ionic compounds dissolved in water that fully ionizes, no. So that means the ions of your salt, no, are separated completely, no. So magkakaroon ka ng positive charge and negative charge talaga. For weak electrolytes, sila yung mga galing sa ionic compounds that do not fully dissociate, no. So, ano yung mga common example nun? Yung mga organic acid or mga organic bases such as uh, acetic acid. Itong suka natin. So, yan ay weak electrolyte yan. Okay? So, kapag nag-pass through ka ng kuryente doon, medyo dim yung ilaw. Pero at least may ilaw. Pero kapag yan ay asin, iilaw talaga yan. Okay? So, ganun lang. Okay, so ito yung table that classifies some electrolytes, no? Some categories ng solute in our aqueous solution to whether siya is strong electrolyte or weak electrolyte. No? So, yan. Kailangan nyo ba ito kabisaduhin? Kahit hindi na. No? Of course, save your mind save your brain space sa mga equations mamaya. Okay? So, ganun lang. So, ayan, no, nakikita nyo, ionic compounds, sila yung usually na strong electrolytes. Pero yung mga weak electrolytes, ito yung mga organic stuff, no, such as acetic acid, ammonia, even water, weak electrolyte yan. No? And yung mga non-electrolyte, ito yung mga molecules that do not have cation nor an ion. Wala silang ganun. Ano lang sila? Molecule lang talaga. Okay? So, yeah. And then lastly, sa qualitative part, so how do we prepare solution? Okay, so last time, nakwento na natin yon. You have your volumetric flask, okay? You will measure certain amount of your solute. Ilalagay mo siya sa loob ng vol flask. Then, you will fill it halfway with water. That's ano yung susunod na gagawin? I-mix-mix mo yan, shake mo yan until your solute are completely dissolved. After that, you fill it up to the meniscus part. Okay? So, since wala tayo sa lab, mag-virtual lab tayo. Okay? So, pakita natin how to prepare solution. Paki-zoom na lang yung inyong screens. Pwede nyo gawin yan eh. Especially kapag nasa cellphone kayo, i-pinch nyo yung ating screen. Gawa tayo dito. Gawa tayo solution. Okay? So, anong glassware kailangan natin doon? Bago glassware, kailangan syempre may timbangan tayo. Okay? So, kailangan may vol flask tayo. O let's say 500 ml vol flask. Ano pa? Yung pagtitimbangan natin ng solute, kailangan may lalagyanan yan. Pwedeng papel, no? Papel talaga yung ginagamit namin sa lab, no? Fold mo lang. Okay. Pero kung mayaman yung lab, no? Especially sa industry, may tinatawag silang weighing boat or weigh boat, no? Okay. So ito yung weigh boat, diyan namin nilalagay yung solutes. No? Pwede rin naman papel. Ifo-fold mo lang siya. Okay? So, pagkalagay mo ng whey boat dyan, tignan nyo, may reading yan, di ba? Zoom in natin. Ayan, may reading yung whey boat. Siyempre, mabigat yan. Container yan eh. So, ano ginagawa natin, no? Kailangan isubtract natin yung mass ng whey boat, no? So, pipindutin natin yung tear. Magsi-zero yan. Okay, so that means kung ano man yung ilagay natin dito na substance, yung mass nun yung lalabas dito. Hindi yung sa whey boat. Okay? Kasi kapag hindi mo tiner yan, masasama yung mass ng whey boat na. So, i-tear mo para mag-zero yan. Okay? So, ganun. So, anong gagawin natin? Kuha tayo ng salt. Kuha tayo ng salt. Ito na lang, sodium chloride. Okay? So, mukha lang itong madali gawin. Pero pag nasa lab kayo, isang oras kayo dyan. Hirap gumamit ng analytical balance sa totoo lang. Okay? So, narito na yung NaCl. Nasa ano na tayo? Nasa, tawag doon, analytical balance. Okay? Maglalagay tayo. Anong mass kaya? Siyempre, kino-compute mo kung anong mass yan. No? May mga equation kang gagamitin to solve for the mass of your NaCl na need. No? Pero sa ngayon, hula-hula tayo. Let's say 1 point, ayan. So, kunwari, yan yung mass ng sodium chloride na need ko i-transfer. Okay? So, yan. So, tapos na ako. Remove ko na yan. Okay? So, andun yung salt ko, hindi lang kita. Okay? Tapos, after mo magtimbang ng ng crystals, no? Na need mo gawa ng solution, gagawin mo dyan, transfer mo yan sa inyong vol flask. Ano yun? 1.253, di ba? Ayun. Meron ng crystals sa ilalim. Onti nga lang. Actually, di ko rin makita masyado. Dagdagan pa nga natin. Sige. Hula-hula na lang tayo. Ayan. 5 grams. 5 grams. Nawala yung solid ko pala. Ulit nga tayo from the top. Nawala ko yung crystals ko. Uso yan sa lab, no? Nagkakawalaan kayo ng chemicals. Feeling ko tuloy nasa lab uli ako. Remove ko nga ito. Remove. Ayan. Kuha uli ako ng salt. Naglalagay uli ako 5 grams. Hindi ko na alam kung ano na yung mass ko. Okay. So, lalagay ko na yan dito sa vol flask. Transfer natin 5 grams. Okay. So, yan, transfer ko na. Zoom in ulit tayo. Okay, so our vol flask has few droplets. May mga few crystals siya ng salt. Medyo white siya dito sa screen ko. Zoom nyo na lang kung di pa kayo convinced. O kaya try nyo rin mag-open ng virtual lab. May link sa end ng lesson natin. Okay, so yan. So once meron ka ng ganyan, okay, ano na gagawin mo? Kuha ka na ng water. Siyempre, yung water galing dapat yan sa beaker na maliit or saan? Sa wash bottle. Pero sa ngayon, yung galon muna. No? Virtual lab lang naman eh. So, transfer tayo to 50 ml ng water. Okay? So, once may water na yan halfway, ano gagawin nyo sa ball flask? Shake, shake na. Shake, 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 shake. Bali-balik ta rin nyo yan. Okay lang. Okay? So, yan. Na-mix na natin kunwari. Kahit kanina pa siya nakamix. Okay? Then, ano gagawin natin? We will fill it up to the mark. Okay? Magfi-fill tayo up to mark. Okay? So, buhos-buhos lang tayo. Hindi ko alam kung anong water level na natin. Basta buhos nyo na lang yan. Okay? Malapit na tayo sa taas. Okay, malapit na. Kailangan mag-lower meniscus tayo. Pag lumagpas ka dyan, ulit ka talaga. Ayan, buhos-buhos tayo, tigi 1 ml until, ayan, dumalapit na. Okay. Kailangan lower meniscus yan. Okay, so medyo lower meniscus tayo, so pwede na yan. Okay. So, ayan. So, ganun tayo magpe-prepare ng solution. No? And then, may corresponding concentration yan. May corresponding molarity yan. Okay. So, that's how you prepare solutions sa lab. No? Daming ganap, no? Yes. So, ano uli gagawin? Mag-uwi ka ng certain amount of your salt. Lalagay mo siya sa ball flask. You fill it halfway. You dissolve the salt, no? And then you fill it up to mark. Again, lower meniscus dapat pag nag-fill ng mark. Okay? So, ganun lang. Okay. So, yun. Tapos na tayo sa qualitative part, no? So, now, let's proceed with the quantitative part, no? Calculation tayo. Okay, so depending on the amounts of your solute in your solution, meron tayong corresponding concentration units for that. No? Okay, so what are concentration units? No? So these are equations, these are ratios, no? Ng amount ng solute with respect to the amount of your solvent, no? So if you have if you have so many solute, ibig sabihin mataas ang concentration mo. If you have few amounts of solute, that means mababa yung concentration. Pero ang question doon, ano yung numerical value? So sinosolve 'yon, okay? So magde-deal tayo with fractions dito, okay? So the following are the common concentration units used in analytical chemistry. No? So number one, we have the percent by mass, percent by volume, molarity, parts per million, parts per billion, and the P functions. Okay? So again, ano uli concentration unit? That's the ratio of your solute amount over the solution amount. No? Minsan solvent, no? Pero uncommon yun. So, ganun. This should be familiar with you, especially sa mga STEM students dati dito, no? Mga molarity, molality, no? So, ngayon, yung ilan lang kukunin natin doon. Okay? So, let's start with percent by mass. Okay. So, when you say percent by mass, that is just the ratio of the mass of your solute over the mass of the solution. Okay. Take note, solution, not solvent, no? Okay, so saan ba gawa yung solution uli? Solution is made up by two components, solute and solvent. Kapag ang binigay sa inyong mass ay mass ng solute pati mass ng solvent, ang numerator ay yung solute, ano yung denominator? Hindi yung solvent lang, kailangan kasama yung solute, okay? Because the two will make up the mass of the solution. Okay? You have to be careful with that. Pag sinabing solution, that is, teka lang, rewrite ko yung equation. That is mass ng solute divided by mass ng solute plus mass ng solvent. Okay? Times 100%. Okay? So, yun ha. Be careful. Solution ang usapan, not just the solvent. Solution as a whole. Okay? So, ganun. For example, may sagot na. Okay, so let's have this one. By the way, next meeting sa Thursday, doon tayo magsasagot ng worksheets. Ha? So sa ngayon, absorb nyo na lang muna yung mga lessons and equation natin. So by Thursday, doon tayo magsasagot and magre-recite. No? Ungraded naman. Okay? So yan. So let's have this one. A solution was prepared by mixing 29 grams of NaCl with 30 grams of water. Find the percent by mass of NaCl. Okay, so again, ano yung solute? Solutes are the substances that exist in small quantities. So that means ito yung ating solute. Okay? Itong water, since water yan, edi solvent yan. No? Automatic yan. Water is the solvent. Okay? Then, what's next? Ipa-plug in mo siya sa equation na to. Okay? So, that's percent by mass equals mass ng solute over mass ng solution. So, in the numerator, you will write 29 grams. So, yun yung mass ng solute. However, in the denominator, hindi yung 300 ilalagay mo. Kailangan kasama yung 29. Bakit? Yung 300, that is just the solvent. Ang kailangan sa denominator is the solution. So, you add the mass of the solvent and your solute, yung sum niyan, yun yung ilalagay mo sa denominator. And by the way, when doing calculations sa percent by mass, the units must be the same. Okay, so that means if this is grams, this other one should also be in grams. Pag ito naka-kilograms, ito kailangan kilograms din. Okay, so the unit should be the same. Okay, so ganun lang. So again, pag sinabing solvent lang, yan, i-add mo pa yung solute. Pero kapag sinabi yung solution, edi yun na lang yung ilagay mo. Be careful ha. So yan. Next one. Again, paki-absorb na lang muna yung materials na. Next meeting, dun tayo magsasagot ng worksheet. Sabay-sabay tayo magsasagot dun. Okay? Tapos magre-recite tayo. Next one, we have the percent by volume. So this is similar with percent by mass. No? But instead of using mass, we use volume units naman. Okay? So yan. So same equation, same concept. Yan. Let's proceed. Bago yung problem na yon, so kuha tayo isang example. Kunwari, I have 5.32 ml of ethanol. And kunwari, nasa ano yan, nasa solution na yan. Kunwari, I have 5.32 ml of ethanol in 352 ml of solution. Find percent volume. Okay, so madali lang yan. So the numerator will be your solute. Okay, so ito yon, solute yan. So nasa numerator ko yan. Divided by yung denominator. Ito ba at ito ay ipag-add ko pa? Ito, pati ito, ipag-add ko pa. Ano sagot? Pwede kayo gumamit ng mic, no? Hindi po, opo, ganun. So, pag i-add ko pa ba yung dalawang yan? Nasagot ay?
Hindi po.
na. Okay, so hindi na. Bakit? Kasi, sabi sa ating question, itong 352 ml na to, ay yun sa solution na. So, that means pinagsamang solute solvent na yan. Okay? So, wag mo na ipag-add yan. Be careful. Bakit ko siya nire-reiterate parate? Kasi pagdating ng quiz, malaki yung chance malito kayo or kabahan kayo. Okay? So, ako na nagsasabi, next week na yung quiz nyo dito eh. So, yun. Be careful lang. Okay? Sana perfect nyo yung first quiz dito. So, divide natin. 352. Okay, so the percent volume of ethanol is 1.51%. So, yun yung sagot natin. Okay? So, be careful lang ha. Ayun. Ngayon pa lang. Careful na dapat. Okay? What else? Since ito ay fraction, pwede natin siya kali-kalikutin. Okay? So, pwede tayo mag-cross multiply, etc. etc. No? So, sana familiar pa kayo sa ganung operations. Okay? So, kapag hindi na, kailangan. Okay? So, aralin nyo ulit. Okay? So, let's try this problem. A certain alcoholic beverage is 10% ethanol in volume. How much ethanol are there in 728 ml of alcoholic beverage? Okay. So, sabi dyan, 10% ethanol in volume. So, kumbaga, ito na yung percent volume. Okay. Then, how much ethanol are there in 728 of the beverage? So, ito na yung volume ng solution. So, ano yung hinahanap? Volume ng solute. Okay. So, we have to look for this one. Sabi sa algebra, if you are solving for an unknown, it should be left, no? Kailangan matira siya without any variables around it, no? Kaya ina-isolate natin yung term na unknown. Diba kaya nga usually x is equal to something, okay? Yung unknown nasa left, yung known quantities nasa right, diba? Okay, so ganun gagawin natin. So yung solute, may kasama yung 100% and V solution. So we have to cross multiply them, no? Kaya pwede naman natin ganitohin na lang. So yung V solution nasa denominator, ano gagawin natin dyan? I-multiply natin both sides by V solution. Ano purpose? Para mag-cancel. Yun nasa denominator. Okay? So sino pa yung kasama ni V solute? Si 100%. Since nasa numerator yan, kailangan i-divide natin both sides by 100% para mag-cancel out sila. Okay, so cancel, cancel, and then you will be left with V solute equals V solution, percent V, and 100%. Okay? So, ba't kailangan ko to i-reiterate? Kahit alam nyo na, hindi nyo alam kung ano mga pwede mangyari na sa quiz. Baka kabahan kayo. So, you have to be very, very careful. Okay? So, ganun lang. So that's V solute equals percent V times volume solution, all divided by 100%. And then you plug in all the info, and then we get 72.8 ml as the volume for your solute, no, which is ethanol. Ayun. So yun. Yun na yun. Next one, molarity. This is the most important concentration unit in analytical chemistry. Okay, so what is molarity? That is the ratio of the moles of your solute over the liters of solution, the volume of the solution in liters. Okay, so yan. So ganun, yun na yun. So mole solute divided by the volume of the solution in liters. Kaso, usually, mass ng solute yung meron tayo. So, how do we convert mass to moles? We use the triangle. Hindi ko lang kung gumagamit kayo dati ng triangle, pero kami ng mga bata ko, Illuminati kami. So, ayan, triangle. So, ito yung mole, mass, molar mass. Okay? So, paano ginagamit yung triangle na to? If you are looking for an unknown, ano gagawin? Tatakpan mo siya. Okay. So for example, I am looking for a mass. So tatakpan ko yan using my mouse cursor. So if I'm solving for the mass, that is the mole times the molar mass. Okay. So i-multiply ko yung dalawang yan to solve for the mass. What if I am solving for the moles of my substance? That's mass divided by molar mass. If I am solving for the molar mass, that is mass divided by the moles. Ganun lang. Okay? So, takip-takip lang. Okay? Pag magkatabi, multiply. Pag isa nasa taas, isa nasa baba, divide. Okay? So, that means we can further rewrite our molarity equation into this. Saan equal yung mole? That is mass divided by molar mass. No? Okay? clear ko lang. So we can rewrite that as mass solute, okay? We have to be specific, over molar mass ng solute. All divided by the volume of the solution in liters. By the way, kapag nakita nyo sinulat ko SOLN, solution yon, sol. Nakakatamad kasi magsulat eh. Okay? So, ganun. Then ano pa? Pwede gawin dito. We can rewrite our equation para mas maging clean yan. We can rewrite that as mass solute divided by molar mass ng solute times the volume of the solution in liters. Okay? So this is the expanded equation for molarity. Okay? So sa mga nagsusulat, pakisulat na lang, no? So molarity, in its simplest sense, that is the moles of your solute divided by the volume of your solution. Okay. However, in terms of mass, we can rewrite that as mass solute divided by the molar mass of solute times the volume of the solution. Okay. So yung molarity, maraming tawag dyan. We can call it molar, pwedeng molarity din, pwedeng mole per liter, o kaya capital letter M. So yan yung mga tawag sa molarity. Pwede rin namang square bracket. Kapag nakakita kayong square bracket sa Anachem, molarity yon. Kunwari, may nakita kayong ganito. Ano meaning niyan? Molarity ng H+. Kunwari, may nakita kayong ganito. Molarity ng silver. Okay? Kunwari, may nakita kayong ganito. Molarity ng chloride. No? So, ganun. Basta may square bracket sa Anachem, that means molarity. Okay? So, ayan yung mga tawag sa kanya. Molar, molarity, mole per liter, capital letter M, square bracket. Lahat yan ay molarity. Okay? Medyo nakakabulol lang. Okay, so, let's try to practice. Let's have this one. Calculate the molar concentration of ethanol in an aqueous solution that contains 2.30 grams of ethanol in 3.5 liter solution. Okay? So the equation is shown already. So chill lang tayo. Next week, next meeting tayo magsasolve talaga. So ayun. To solve for the molar concentration, we use the formula for molarity. That's molarity equals mole of your solute per volume of the solution in liters. Okay? So you plug in all the info. This is the mass of your solute, molar mass of your solute. This is the volume of the solution in liters. Then you will get the final answer, 0.0143 molar or capital letter M. Molarity yun. So, ganun lang. Okay. Next one. Again, no, sa mga nagsusulat, nasa PowerPoint na naman yung entire solution na to. No? Pwede naman tignan nyo rin after the class. No? Kasi by Thursday, dun tayo magsasagot talaga. No? Sabay-sabay tayo magsasagot nun. Okay? So, wait lang kayo sa worksheet. No? Upload ko yun sa Thursday. Okay? Next one, we have this problem. Describe the preparation of 2 liters of 0.108 molar barium chloride from barium chloride dihydrate. No? Excuse me. Nahulog lang. Okay, so we describe the preparation of 2 liters of 0.108 molar of barium chloride from barium chloride dihydrate. Okay? So, ibig sabihin yan, our solute is barium chloride dihydrate. No? Tapos, from this molecule, kukuha tayo ng barium chloride. Okay? Ito yung question. Ano yung stoichiometry? Ano yung ratio ng BaCl2 sa BaCl2 to H2O? How many BaCl2 can we get from BaCl2 to H2O, barium chloride dihydrate. Sige. Ano yung ratio nila? Sagot ay 1:1 lang. Okay. Paano nyo malalaman na 1:1 yan? Tingnan mo lang yung formula. Sa formula na to, ilang BaCl2 makikita nyo? May coefficient ba yan? Wala. Isa lang naman. So, that means kung ano yung mole ng BaCl2 na kailangan, ganun din yung moles ng BaCl2 to H2O yung kailangan. Okay. That is suggested by the formula naman. Okay. So, yun. 1:1 lang yung ratio nila because the formula is similar. Nadagdagan lang ng 2H2O. Okay. So, ganun. So, that means, alamin muna natin kung ilang moles neto ang kailangan. Okay? So, we have 2 liters volume. We have 0.108 molar. Yun yung concentration. Can we now solve for the moles of BaCl2, na barium chloride? Pwede, no? Paano natin masosolve yan? Moles neto. Using the molarity equation. Recall, molarity is equal to mole over volume in liters. Paano makukuha yung mole dyan? Tignan nyo. Cross-multiply lang. So, mole is equals to molarity times the volume in liters. So, alamin muna natin how many moles of barium chloride ang kailangan. So, that's mole times 2 liter times 0.108 mole per liter. So, I am expanding the units so we can see that they will cancel. Liter, pati yung liter, magka-cancel. Therefore, I need 0.216 mole of barium chloride. Okay? However, the source of barium chloride is this one, barium chloride dihydrate. Ano yung ratio nila? Sabi ko kanina, 1:1. Okay? Ang difference lang naman ay yung H2O. So, hindi naman nagmamatter yan masyado. Okay? So, that means, ito ay equal din sa ganong dami din ng barium chloride to H2O. Okay? So, ganun lang. Baka isipin nyo, sir, bakit kailangan gawing barium chloride to H2O? Sabi kasi ng problem, dito tayo kukuha ng BaCl2. Okay? Kung hindi sinabi ng problem dyan, edi ito na yung moles nun. Ko-convert na lang natin sa mass. Pero sabi ng problem, dito daw tayo kukuha. Edi, no choice. 1:1 lang naman. So, okay na rin. Okay? So, ganun lang. Then, what's next? Okay? So, ito yung solute natin. Yan. Ano susunod natin gagawin? Hanapin mo yung mass niyan. Okay? So, you have to convert 0.216 mole of barium chloride dihydrate into that mass. No? So, punta lang kayo sa next slide. Andun na yung conversion niya into mass. No? So, we solve for the mass of BaCl2 to H2O. That's given by this equation. Anong equation ginamit dito, sir? Yung triangle. Okay? Lahat ng equation sa mundo gumagamit ng triangle halos, no? Tignan mo molarity. Molarity, mole, volume in liters, 'di ba? Ikot-ikot ka lang diyan. Tignan mo yung mass-mole relationship. Ito, mole, mass, molar mass, 'di ba? Triangle ulit. Okay? So ganun. So yan, to solve for the mass of to solve for the mass of the barium chloride dihydrate, we multiply the moles given earlier with its smaller mass shown here sa problem. Okay, so just multiply them and then you'll see you need 52.8 grams of barium chloride, 2H2O, and then you will dissolve it with enough water up to 2 liter mark. No? Okay, so try natin yun sa virtual lab natin. I don't know if meron akong barium chloride dihydrate dito. Tignan ko lang kung may barium chloride dihydrate ako. Wala ata akong barium chloride dihydrate dito. Pero ipapakita ko na lang kung paano. Okay. So kung paano yung ginawa natin kanina, ganun din uli gagawin natin ngayon, no? So zoom nyo na lang ha. So kunwari ito na lang yung barium chloride dihydrate. Okay. Kuha lang tayo timbangan. Ayan. So patong natin yung weighing boat sa timbangan. Paki-tear. Okay. Ano yung purpose ng tear? Para makancel na yung mass ng weighing boat. Okay. So since 1 liter ano lang tayo, 1 liter solution lang meron tayo, i-divide na lang natin to sa 2. Okay. 2 liters kasi ito eh. Okay, so kung 1 liter lang meron tayo, divide mo na lang yan sa 2. Parang ganun. Okay. Wala kasi tayong barium chloride eh. Bibili pa tayo sa Bambang. Okay. Anong mass? 26.4. Okay. Ayun, so meron ako doon 26.4 ng sodium chloride. To-transfer ko yan dyan. 26.4. Enter. So, andun na yung aking solid sa loob ng vol flask. Pwede nyo i-zoom yung screen nyo. Kunwari, you have your iPad with you or your phone. Paki-pinch na lang para ma-zoom. Okay? Pag nasa laptop, hindi ko alam kung paano mag-zoom. Okay. Ganun na lang kayo. Squint na lang eyes ninyo. Okay? So, yan. Tapos, anong gagawin? Water halfway. Dito, galon na. Palaki ng palaki yung container natin ng tubig. No? Transfer muna tayo ng kalahati. 500 ml. Ayan, kalahati. Tapos, anong gagawin natin? Pagka-transfer ng kalahati, shake, shake, shake. Okay? Shake, shake, shake lang. Shake, shake. Bali-baliktaran nyo. Tapos after nun, pag tunaw na, i-fill it again with water. Ayun. Wala nyo ba't nawala ng internet? Yung Converge, nagloloko na naman. Anyway, so may backup naman akong globe. Ayan. Kita nyo na ba uli yung screen? Okay. Balik ulit tayo. Buti pa kayo hindi kayo naka-converge, no? Sa una lang sila magaling. So anyway, so yan. Ah, ano gagawin natin diyan? Halo-halo nyo lang. Mix, mix. Until, ano na yan? Until dissolve na. Transfer ako ng 400 ml. Ay, ala, lumagpas. Ala, lumagpas ako sa ano. Lumagpas yung tubig ko sa beaker. Ulit ako nun from the top. Okay? So, basta ganun. Ang hirap kasi kapag galon yung gamit. Eh. Pero anyway, so ganun lang yung idea, ha? Basta lower meniscus lang. Parang yung pinakita ko kanina. No? Lagpas to. So, ulit ako from the top. Okay? So, ganun lang po. Ay, nawala din maski yung ano ko. Maski yung screen mirroring ko nawala. Okay. So, ganun lang. Okay? So, yan. Next, concentration units. Dalawa to. So, parts per million and parts per billion. So, what's the difference between the two? No? So, ano bang difference niya compared to other concentration units? No? Ang difference ng parts per million and parts per billion is that ginagamit lang siya. Mamaya may kinalaman yung water bottle dyan. Okay. So we use ppm and ppb kapag ang ating solute, pati yung ating kapag yung ating solute ay super duper onte yung dami niya. Now, very, very tiny amounts of solute in our solution. To give you an idea, imagine nyo, 1 liter ng tubig, lalagyan nyo siya ng isang pinch ng asin. Mag-pinch kayo ng asin, halo nyo doon. So, doon kayo pwede gumamit ng ppm and ppb, o parts per million or parts per billion. Why? Because if you use percent by weight o kaya percent by volume o kaya molarity, ang magiging concentration nyo ay super duper tiny. So, pwedeng 0.000 something. Okay? Maraming zero before you arrive with the first non-zero digit. So, pwede ganun yung maging result kasi. That's why, for very, very tiny amounts of your solute, we instead use ppm and ppb rather than molarity. Okay? So, saan to ginagamit? For example, sa tubig, no? For example, yung Maynilad or yung water bottle na to. So kung makikita nyo, every time na bibili kayo ng water bottle, sa likod, may mga ganitong info. Nakalagay calcium, magnesium, sodium, potassium, bicarbonate, sulfate, nitrate, chloride, etc. Okay? So, itong mga to, these are the ionic compounds that are present in the water bottle. Okay? Or let's say, for example, this is 1 liter bottle of water. And ito yung ppm, yung milligram per liter. Yung mg per L, ppm yan. Parts per million yan. So it tells us na 104 milligram of calcium ay dissolved in 1 liter of water. Okay? Ito yung question. Gaano po kaonte yung 104 milligram? So imagine nyo, kuha kayo toothpick. Okay? Tapos yung toothpick na yun, itusok nyo sa asin, tapos itaas nyo. Yung asin na didikit dun sa ibabaw ng toothpick, yun yung milligram na mass. Okay? Yun yung ihalo nyo sa 1 litrong tubig. So, super onti yung concentration ng solute in your solution. So, that's why we have to use this concentration units, the ppm and the ppb. Bakit? Because super onti yung concentration. Okay? So, saan to ginagamit? ppm, ppb? Pag onti yung solute sa solution. Okay? So there are two ways to use ppm and ppb. Pwedeng by mass, okay? Pwede ring mass per volume. So again, two ways yan. Pwedeng mass ng solute over mass ng solution. Pwedeng mass ng solute over liters of solution. Okay? Either way naman, same pa rin yung makukuha yung sagot na. Okay, sa Anachem, we use this one, the mass per volume. Mas madali kasi siya gamitin. Okay? Pero kapag mass yan, that is just the ratio of the mass of solute over the mass of solution. The two units should be the same kasi parehas mass yan para mag-cancel out yung unit. For ppm, you multiply the ratio by 1 million, 10 raised to 6. No? Multiply mo yan by 1 million. No? Okay? Para makuha yung ppm. Kaya nga per million eh. Kasi minumultiply siya by 1 million. Ganun din sa ppb. Yung ratio nila, imumultiply mo by 1 billion or 10 raised to 9 para makuha mo yung per billion na dami ng solute sa inyong solution. Okay? So the other equation is itong nasa kabila. So that's milligram of solute per liter of solution for ppm. Okay? If you get the ratio of the two units, no? That's equivalent to 1 million then. Okay? So 1 million lang din yung ratio nila. Okay? So ganun din dito. This is microgram per liter naman. Okay? Pag kinuha mo yung ratio niyan, that's 1 billion then. 1 billion din yung ratio niyan. Okay? So ito yung gamit natin sa Anachem because we are dealing with liquid samples at most. Okay? So ganun lang. Let's have some few examples lang. For example, a certain water has a calcium concentration of 36 ppm. What is the mass of calcium in 500 ml of the water? Okay, so since our solution is in liquid form, no, naka-water siya, naka-volume unit siya, so we use the equation of ppm that is in terms of mass and the volume. Okay, so ito. So again, ppm, parts per million, is equal to milligram of your solute divided by the liters of your solution. Ano yung hinahanap? Ang hinahanap sa problem ay yung mass ng calcium. Okay, so we have to rewrite the equation. We multiply both sides by liter of the solution para mag-cancel out ang dalawang terms. Okay, cancel. So you will have milligram of solute equals ppm times the liter of solution. Okay. By the way, ang unit for ppm ay mg per L lang din. Okay. So you place 36 ppm or 36 mg per L times the volume of the solution in liter. So that's 500 ml. Convert nyo yan to liters. That's 0.5 liters. Multiply that, magka-cancel yung liters. So you have 18 milligrams of calcium in your water bottle. No? Gaano po kabigat yung 18 milligram? Hindi siya mabigat. No? Magaan lang yan. Okay? So, ganun. Okay na uli yung converge. No? Ewan. Globe muna tayo. Okay. So, last one. The last one is the P function. Okay, so P function, this is actually from mathematics, no, na kinuha lang ng chemistry. Okay, so when you say P function, we are actually pertaining to the negative logarithm. Okay, the negative logarithm of the molar concentration of our species. No? Okay, so again, sabi ko, kapag may square bracket, that means molar concentration. So let's say our substance is X. No? So Px is equals to the negative log of the molar concentration of X. Ano yung p-value na familiar tayo? Yung pH. So that means pH is just the negative log of the concentration of H in your solution in ionic form, H+. Okay? Ano pa? pOH. No? O yung pOH, that's negative log of the concentration of OH, no, in your solution. So, ganun. So, alam nyo naman, pH and pOH, may values yan ranging from 1 to 14, di ba? Okay. Mali-discuss natin yan kapag nandun na tayo sa topic na yun. Okay? So, sa ngayon, ito lang muna. Okay? Ano pa yung mga pwede gamitan ng P value? Kahit ano, actually. pwedeng PAG. That means negative log ng concentration ng silver ion. Kunwari, PCl, ibig sabihin niya, negative log concentration ng Cl minus, etc. Okay? So, basta may P, ang meaning nun ay negative log. No? So, P, negative log, pH, negative log ng H, POH, negative log ng OH, PAG, negative log ng AG. Okay? So, ganun lang. So, if you're given a certain mass of your substance in your solution, kunin mo muna yung molar concentration, then eventually, kunin mo yung kanyang pH. Excuse me. By placing the concentration value into the negative logarithm. Ito yung question. Sir, pwede po ba from px or pH, kunin ko yung value ng x or kunin ko yung value ng H plus, yung concentration niya. Pwede yun. Kasi mathematics to, no? Lahat ay posible. Okay? So, ano pwede natin gawin dito? So, di ba itong concentration na to, from H plus to pH, itong equation yung gagamitin natin. Okay? So, negative log of concentration nito, pH yun or px, no? What if gusto natin baliktad? O kunwari from pH, gagawin mo siyang concentration ng H plus. Or let's say px to concentration of x. Pwede yan? Pwede. Ang gagawin, properties of logarithm. Okay? So, paano yan? O, kopyahin mo muna yung original equation. Let's say px equals negative log concentration ng x. So, anong gagawin? Iyak na tayo. Hindi. Multiply both sides by negative 1. Okay? So, yan. So, we have negative px equals log x. Then, anong gagawin? These numbers, itong dalawang to, pwede natin siyang gawing exponent ng 10. Okay? So, gagawin natin 10 raised to negative px equals 10 raised to 10 raised to log x na. So, equal pa rin yan. Okay? Kasi parehas yung base ng ating exponent. Ano? So, parehas silang 10. So, equal yan. Then, anong mangyayari? Sabi ng algebra, kung naalala nyo pa yung GenMath, ang sabi ng algebra, ang logarithm and yung 10, pag sila ay naging mag-exponent ng isa't isa, what happens? They will cancel out. Okay? So, this can be written as the concentration of x equals 10 raised to negative px. Okay? So, that means we can solve for pH from the concentration of x and at the same time, we can do the reverse. Pwede natin baliktarin. Okay? So, you just have to remember this formula. Okay? Sorry. Yung derivation kahit di na. Yan. So, ganun ha. Yan. O, pwede natin balik-baliktarin, no? From H to pH, ito yung gagamitin. From pH to H, ito yung gagamitin. Okay? So, anyway, puro algebra lang naman to. No? Kayang-kaya nyo yan. Now, let's proceed. No? Let's have this one. A solution was prepared by dissolving 0.52 grams of NaCl to make 250 ml solution. What is PNA plus? So, ano daw yung PNA? Okay? Ano gagawin natin dyan? Ano ba kailangan para ma-solve yung PNA? Kailangan natin ng concentration ng Na+. How are we going to solve for the concentration of Na+? They will start with our given substances. Okay? Sabi dyan, we have 0.52 grams of NaCl dissolved in 250 ml solution. Okay? So, edi kunin mo yung molarity niyan, no? So, this is the solving part. Ito daw yung molarity. Okay? Ito question. Sir, NaCl yan. Ang gusto natin, Na. Paano yun? This stoichiometry lang. Okay? So recall the dissociation of NaCl. Ang NaCl, pag nag-dissociate yan, isang Na plus at isang Cl minus. So, anong gagawin natin dyan? Kung ang Na ay 0.036 molar, that means Na plus is also the same. Okay? So, ganun din yung iba na. So, ganun. Sir, paano nyo po malalaman kung same lang sila or hindi? Baka nanguhula ka lang. Ganito, para malaman nyo kung same sila, just look at their coefficients. No? Anong coefficient ng NaCl? Isa. Ano yung coefficient ng Na doon? Isa lang din. So that means, kung ano yung molar concentration nito, whatever the molar concentration of NaCl, that is also the molar concentration of its ions. Okay. Sir, paano kunwari may 2 dyan? Kunwari, kausap ko talaga sarili ko, yes. Kunwari, sir, ganito, BaCl2. 'Di ba magiging Ba plus 2 yan and dalawang Cl minus. Naalala nyo pa ba yung dissociation reactions? Nung precipitation reaction, diniscuss yan last sem. So, kailangan naaalala nyo siya, ha? So, kunwari po, ito, 0.5 molar yan. O, ano yung concentration ng Ba plus? Tingnan mo yung stoichiometry. Ano coefficient nito? Isa. Ang coefficient nito, isa. So, ibig sabihin, kung ano value nito in molarity, yun din yung value nun in molarity. Okay? 0.5 molar din yan. Ay, sir, paano yung Cl? May 2 doon. Ibig sabihin nun, times 2 yung concentration niya. Okay? So, yun yung purpose ng stoichiometric factors. No? Nasa solution stoic na tayo actually. No? So, yan. So, the stoichiometric factors, sila yung nagiging multiplier ng concentrations natin. Okay? So, we will discover more of this sa Thursday. No? Kasi marami tayo sa solve doon. Okay? So, that means kung ano yung concentration, going back sa problem, kung ano concentration ng NaCl, yun din yung concentration ng Na+, and yun din yung concentration ng Cl-. And since we are looking for the concentration of Na+, you just copy this number. Ayan, yung 0.036 molar. Copy mo lang yan. And then, ipasok mo siya sa equation. So, you just press your calcu, negative log 0.036, walang units, equal to 1.42. That's how you solve for P and A. Okay, so ganun lang. Ito naman, next one. A juice has a pH of 5.31. Find the concentration of acid, H+, in the juice. Now, so we are given pH and then we are looking for the concentration of H+. Ano gagawin? E di yung second equation, di ba? Remember, from pH to concentration ng H, ano gagawin? Concentration ng H is equals to 10 raised to negative pH. Always remember this formula. Ito yan na. X is equals to 10 raised to negative px. Yung x, papalitan mo lang yan ng kahit anong substances. Okay? So, gagawin lang natin to solve for the concentration of H+. That's concentration of H+ equals 10 raised to negative px, which is 5.31. Solving for that, we will get 4.9 times 10 raised to negative 6 molar. Okay? So, yan. Matapang na yan actually. Mataas na yung concentration na yan. Kaya maasim yung suka. Yung juice. No? Pag tinasam mo ba yung concentration yan, masusunog na yung yung tissues mo kapag ininom mo yan. Okay? So, ganun lang. Okay, so we're done with the concentration units. This time, proceed tayo sa dilution. Okay. So, what is dilution? So, dilution is a procedure that makes your solution less concentrated. No? So, ito yung ginagamit natin kapag tayo nagtitimpla ng juice. No? Kunwari, nagtitimpla ng juice. Kunwari nasobrahan mo ng nesty. Kunwari 3 nilagay mong nesty, hindi mo matansya, eh. Tas tinikman mo yung 1 litrong tubig. Ano lasa nun? Super tamis. Ano i-a-advise sa inyo ng parents nyo? Dagdagan mo ng tubig, no? So, yung process by adding water sa inyong solution, that's called dilution. Okay? So, dilution yung pagdagdag ng water. Ano yung purpose? Para yung juice, hindi siya ganun katamis. Or, in chemistry terms, so that your solution will be less concentrated. Okay? When you add solvents, nagbabago ba yung amount ng solute? Hindi. No? Kasi solvent lang dinadagdag mo, eh. Ano yung mga nagbabago kapag nagdagdag ka ng water? Yung amount ng solvent and then yung volume ng solution. Pero yung solute amount, same pa rin all throughout. Okay? Okay, so since nagbabago yung volume, that means when you add water, what happens to the molarity of the solution? It will decrease, no? So punta tayo sa ating virtual laboratory para makita natin yan. By the way, yung link nasa dulo ng lesson, sa dulo ng PowerPoint. So, yan. Balik tayo sa ating lab. Okay? Ito yung ating pambasa ng concentration. Okay? Maglalagay ako ng certain amounts ng solute. Okay? Okay. So, yan. So, I have specific amounts of solute dito. Okay? So, ito din yung kanyang concentration. Yan ay 0.870 mole per liter. Ano mangyayari if I add water? The amount of solute will remain the same. Same pa rin yung moles niya. Ano lang magbabago? Yung volume and at the same time yung molar concentration. Dagdagan natin ng tubig. What happened to the concentration? Nagbago. Okay? So, yun yung dilution. By adding water to your solution, what happens is that the concentration decreases. Punta naman tayo sa isa pang virtual lab natin. We have the same solution. Ang gawin natin 1 mole. Hindi, ito na lang. Ito na lang. I have 0.5 moles of my copper sulfate. So what will happen to the concentration? Itong nasa right side. If I add water. Bumababa. No? So ganun yung dilution. No? By adding water, the concentration of your solution decreases. Okay? So ganun. Yun eh. Okay? Ayun lang. Mamaya gagawa ulit tayo dito sa ating workbench. No? Mamaya na yan. Okay? Asan yung PowerPoint ito? Okay. So ganun lang. So balik ulit tayo dito sa concept. So since our solutes, the amount of our solute here remains the same, that means the mole of solute will remain the same. Okay? So if you want to dilute something and you want to find out the final concentration, pwede mo ma-solve yun, no? Using this equation, MIVI equals MFVF. No? Para siyang gas laws, Boyle's law. P1, V1 equals P2, V2. Ganon din dito. Kasi ang nangyayari, constant lang yung ating solutes, pero yung ating molarity and yung volume, they change. No? Ano ba yung equation ng molarity? 'Di ba mole per volume 'yan. Let's solve for moles, no? Mole is M times B, molarity times volume. So kung ano yung molarity and volume sa initial condition, equal 'yan sa mole ng substance. Kung ano yung molarity times volume sa second condition, equal pa rin 'yon sa same mole of substance. So kung ito at ito ay parehas equal, that means the two are also equal. Okay, so that's why we were able to come up with this equation. MIVI equals MFVF. No? Maraming versions tong equation na to. Pwedeng M1 V1, M2 V2. No? Pwedeng MeV, MFVF, kaya C1, ano yun? C1 V1 equals C2 V2. Pero same pa rin yung concept nila. Okay? Hindi kasi nagbabago yung moles. Yung molarity and volume lang yung nagbabago. Okay? So, proportional yung changes na yan. Okay? So, yeah. Now, let's try to use this equation. So, how would you prepare 60 ml of 0.2 molar nitric acid from a stock solution of 4 molar nitric acid? Dissect natin yung problem. Ang daming numbers. Okay. So, usually, yung complete details, ito yung final condition. Okay? So that means the final volume is 60 ml and the final concentration is 0.2 molar. Kaya ayan, nilagay ko na dyan. Final molarity, 0.2. Final volume, 60 ml. Ano yung original ko na solution? So I have 4 molar of nitric acid. Pero ang tanong, gaano karaming nitric acid ang needed ko para same siya ng moles as to our final solution? Okay? So to solve for the volume, the initial volume of our original solution that will give us the same amount of substance or the same amount or of solute as to our final concentration, we use the formula MIVI equals MFVF. We solve for VI. Ito yung nawawala eh. Okay, so you just divide both sides by MI, and then we were able to see not 3 liters ng nitric acid. 3 ml pala, sorry. 3 ml lang nitong original solution ang kailangan to prepare this concentration. Okay? So, ang kailangan natin gawin, we dilute 3 ml of the acid with water to a total volume of 60 ml. Okay? So, pag nahalo natin yung 3 ml ng 4 molar nitric acid to 60 ml water, magiging 0.2 molar na siya. Okay? So, I'll give you some more example using our virtual lab. No? Balik tayo sa ating laboratorio. Linisin lang natin yung bench natin. Ayan. Dilution tayo ha. Practice tayo. Gawa tayo theoretical problem. Okay. So, teka, tignan ko lang kung ano available na chemicals dito. Okay, so I have this one. So, we'll start with 11.6 molar HCl. Gusto ko gumawa ng 250 ml na, let's say, 0.5 molar HCl. How much of the original of the original substance ang need ko? Yes po. Ay, kala ko magre-recite. Oh. So ito yung ito yung ating case. So this is my stock solution, 11.6 molar HCl. Gusto ko from this solution makagawa ako ng 250 ml na 0.5 molar HCl. So ito yung final solution ko. Ang question doon is how much of the original solution ang kailangan to prepare this final solution. So anong gagawin natin? Yung formula. Anong formula? Dami eh. MI, VI equals MF, VF. Hanapin natin how much of the original ang needed. Okay, so VI equals MF, VF over MI. Then plug in natin lahat ng info. So MF, final molarity, 0.5. Ano yung final volume? 250 ml. Ano yung initial molarity? 11.6 molar. solve natin. Gano'ng karaming original substance ang needed. Okay? Sabi ng calcu, 10.70, round up ko na, 10.78 ml. So that means I need 10.78 ml of my original HCl solution, then i-dilute ko siya up to 250 ml para maging 0.5 molar siya. Okay? So gagawin natin yan. Okay? Kuha lang tayo ng glasswares. Kailangan natin ng vol flask, volumetric flask. Ay. Ano ba naman to? Ayan, glassware, vol flask, kuha tayong 250 ml. Pipettes. Okay, kuha tayo pipette. Puno agad yung workbench. Yung upuan ko yung tumutunog, hindi ako yun. Anyway, kailangan mag-pipette ka, no? Hindi mo to pwede ibuhos doon. Pero, since puno na daw yung workbench ko, sabi niya, edi eto na lang. Ito na lang. Buhos na natin doon. Pero again, gagamit kayo ng volumetric pipette, ha? Okay. So, yan. More pipette ang gagamitin dyan. Transferring pipette. Naalala nyo pa ba? Hindi na. Kailangan maalala nyo yan. Okay? So, yan. Magta-transfer ako ng 10.78 ml ng concentrated acid sa aking vol flask. Okay? Okay. So, ando na yung 10.78 ml ko ng acid. Ano na gagawin ko? Pwede mo na yan dagdagan ng tubig, no? Up to mark. Okay, so pwede na yan. Buhusan natin siya ng tubig. Again, lower meniscus. Be careful. 10 ml. Tigta 10 ml tayo. Add. Tignan nyo yung concentration dito. Kailangan ng final na makuha natin ay 0.5. I-monitor nyo to. Dadagdagan ko lang ng tubig. Malapit na. Wait lang. Dadagdag ako ng 0.22. Okay. Tigi isa na yung increment ko. Yung final molarity natin, check nyo. Kailangan 0.5 yan, ha? Isa-isa na tayo. Kasi 241 ml na eh. Okay. Lower meniscus. Okay, so yan, 250 ml. Tignan nyo yung molarity ng H+, 0.5. Okay? So, ibig sabihin, tama yung pinagsosolve natin. No? So, we just get 10 ml, 10.78 ml of our original acid. Then, nagdadagdag ka ng enough water until it reaches 250 ml volume. So, your final concentration is 0.5 liters. No? Ay, 0.5 molar. Okay? So, yan. Check nyo. H+, 0.5. Ibig sabihin, tama yung ginawa natin. Okay? So, that's how you dilute, no? And that's how you prepare solutions sa laboratory. So, yan. After this class, pwede maglaro-laro kayo dito, no? Okay lang yun. Hindi ko kayo i-judge, no? So, yan. And so, that's dilution. Okay? And then last one, solution stoichiometry tayo. So basically, stoic lang to. Mabilis ang daanan lang natin to. Kasi alam ko, aaralin nyo rin to after this class. No? Para sa Thursday, bibukid tayo. Mag-stoic tayo dun eh. Okay? So let's answer this. Solution stoichiometry. Quick reviewer lang. So what are the equations that we use when doing when doing stoichiometry? I think usual process, di ba? Usually we start with our given substance, and then we get our desired substance now. Ang ginagawa ko, nililabelan ko yan. Yung given substance ay yung substance A natin, ang desired substance natin ay yung substance B. Okay? The first steps, no, itong mass to mole, mole to mass, this is just the triangle, no. Yung equation lang yan ng triangle. Mass-mole relationship lang yan. Ito lang yun, no. Mole to mass, gamit ka lang ng triangle dyan. Saan yung stoichiometry dito, sir? Ang stoichiometry ay yung in between the two substances. If you're going to convert moles of substance A to moles of substance B, that's the stoichiometry. Conversion using stoichiometric ratio or the coefficients of the balanced equation. Okay? So dito lang nangyayari yung stoic. Pero the rest, ano lang yan? Mass-mole relationship. Pero since na-discuss natin yung molarity, we can also solve for the moles of the substance using molarity. You just have to multiply the molarity and the volume in liters. No? Pag pinag-multiply mo to, you will get mole. Pag mass naman yung given, you divide it by molar mass, you will get mole. Okay? So, any of the two, yan, pwede mo gamitin to solve for the mass-mole relationship. O kaya, molarity-mole relationship. Okay? So, ganun lang. So, ano lang yung nadagdag sa atin dito compared to your stoic last sem? Ito lang yung nadagdag, yung additional equation for mole. Okay? So, the rest are the same pa rin. So, let's have some few example. Mabilis ang tingin lang tayo. Next meeting, dun tayo mag-actual solving talaga. Na. Kaya nilagay ko na lahat ng solutions dito all at once. Okay? So what mass? Given the balanced equation. By the way, balanced equation dapat. Pag hindi balanced, i-balance. No? What mass of silver nitrate is needed to convert 2.33 grams of sodium carbonate to silver carbonate? Okay. So, ano yung given substance? Hulaan nyo. Di yung may mass. Yun yung given substance. No? So, this will be my given substance. Okay. Then, ano yung desired substance? Yung tinatanong, di ito, silver nitrate. Okay. So, this is my given, sodium carbonate. Ang desired ko ay silver nitrate. Don't confuse don't confuse yourselves. Baka ang kunin mo is yung silver carbonate. Hindi yan yung hinahanap. Ito yung hinahanap. ML lang yun. Chismis lang yan. Ito yung hinahanap talaga. Okay? So again, this is your given. This is your desired. Not the silver carbonate. Okay? So anong gagawin nyo? So to solve for the mass of silver nitrate needed to carry out this reaction, ano pwede mo gawin? Sabi dito sa ating table, you convert the mass of your given to the moles of your given substance. Okay? Paano yon? Mass over molar mass yan. So this divided by the molar mass, which is 106. Divide mo lang yan, you get the moles of your sodium carbonate. Asan step ka na? Andito ka na. Moles. Then ano yung next? Stoichiometry na. You will convert the moles of that substance A to the mole of the substance B from your given substance to the desired substance. How? Using stoichiometry. Okay? You check the coefficients now. So you start with this given substance. This is the mole of sodium carbonate. And then you will convert that into the moles of your silver nitrate. Okay? Just look at the equation, no? How many moles of sodium carbonate ang equivalent sa silver nitrate? 1 to 2 ang ratio nila. Isa for sodium carbonate, dalawa for silver nitrate. Okay? So 2 to 1 or 1 to 2 yung ratio nila. Okay? So ganyan. Then anong gagawin? Kung ano yung value niyan, ilagay mo dyan. Sodium carbonate will cancel out, giving you silver nitrate. No? Okay. Nandito ka na sa part na yan. Nandito ka na sa mole ng desired substance. meron ka ng mole ng silver nitrate na gusto mo. Okay? Then after that, since ang tanong ay mass, last step nyo na yan, from mole to mass, multiply mo lang yan sa molar mass and then you will get the answer. 7.48 grams of silver nitrate is necessary to carry out the conversion of 2.33 grams of sodium carbonate to silver carbonate, assuming that the reaction yield is 100%. Okay? So, yan. So, ganun lang. Basic stoic lang yan. Wala pa tayong dinadagdag na additional stuff, ha? So, kung naalala nyo pa to, very good. Pag hindi na, not so good, no? Aralin nyo para good na ulit, no? So, ganun. Kasi sa Thursday, sasagot tayo, ha? May magre-recite sa inyo. Okay. Hindi siya graded. Lang. Okay, so next problem. Question, what mass of silver carbonate will be formed? No? So, kanina, alam natin that 0. Ano yun? 0.022 mole na ng sodium carbonate ang kailangan to carry out the reaction and 0.044 mole na ng silver nitrate ang kailangan to carry out the reaction. Okay? Kung mapapansin nyo, nagmamatter talaga yung coefficient. Okay? Since ito may coefficient na 2 to, so that means times 2 mo yung times 2 mo yung amount of substance. Okay? How about silver carbonate? Ang tanong kasi, what mass of silver carbonate will be formed? So you begin with this one. Kung 0.22 ito, this one should also be 0.022 mole. Okay? Bakit? Kasi 1:1 ang ratio nila. This is 1, that is 1. So kung ano yung moles niyan, yun din yung moles nun. By stoichiometry. Okay? So ganun. So kung ano yung moles nito, yun din yung moles noon. By stoichiometry. Okay? So yan. Huwag mo na gamitin to. Magdi-divide by 2 ka pa eh. No? So ito na lang. 1:1. Doon ka kukuha ng info. Okay? So since we know 0.022 moles of the silver carbonate will be formed, para makuha mo yung mass niyan, you just multiply it by the molar mass and you will get 6.07 grams of silver carbonate. No? So yan, that's the final answer na. Next one, ito, may inad na tayong additional info dito. Anong inad nating additional info? The use of molarity. Okay? So let's look at this example here. Okay, so let's look at this example. What mass of silver carbonate is formed when 25 ml of 0.2 molar silver nitrate are mixed with 50 ml of 0.08 molar sodium carbonate? Tignan natin yung given para mas magkaroon tayo ng idea how to answer this problem. No? So tignan nyo yung given substances nyo. Again, na-discuss na rin naman to last sem. Nire-recall lang natin and dinadagdagan natin ng onting additional info. Okay, so anong given substances? 25 ml of 0.02 molar silver nitrate. Ito yon. Sulat natin. 25 ml. Ka lang. Masyadong malaki. So, 25 ml, 0.2 molar silver nitrate are mixed with, teka lang. Oy. Are mixed with, 50 ml of 0.08 molar sodium carbonate. Okay, 50 ml. 0.08 molar. Ano napapansin nyo sa problem na to? Yung dalawang given na substances ay reagents or reactants. Anong topic to sa stoic? Letter L. Limiting and excess. reagent to. So, may ganito sa Anachem uli. Limiting and excess reagent uli na. Okay? So, paano ba sinasagutan yan? Ito yung maraming calculation. Okay? So, ganito gagawin nyo. If there are two given reactants, two amounts of reactants are given, no? Ano gagawin nyo? Huwag kayo iiyak. No? Ang gagawin nyo, you convert the mole of this substance to your product. You also convert this into the moles of your product by stoichiometry. Parehas mo sila i-convert to the product. Then what's next? You check kung sino may lowest yield. Sino may pinakamababang amounts na maibibigay. Yung may pinakamababa na amount na maibibigay, yun yung limiting reagent. And then yung natirang reagent, yun yung excess reagent. So what's the theoretical yield? Yung final yield mo. Ito yung sa limiting reagent, di ba? Naalala pa ba? Hindi na. Pag hindi naalala, balikan ang stoichiometry. Nandun yung sa playlist natin sa YouTube. Panoorin nyo na lang. Okay. So chapter 3 yun. Chapter 3 ba? Chapter 4 pala. Chapter 4. Panoorin nyo na lang. Hanapin nyo sa playlist. Kahit anong section, piliin nyo doon. Panoorin nyo, chapter 4, day 1, day 2, yun, stoichiometry yun. Okay? So, yan. Pero kung kaya nyo naman magbasa by book, edi good. No? Kung gusto nyo video, balikan nyo na lang yung videos last sem. Sa kabilang playlist yon sa YouTube channel natin. Okay? Okay, so going back, again, ano gagawin natin? We convert this amount into moles of this substance to the product. Ganun din dito. Convert mo muna to mole, then convert mo siya to our products. No? So since molarity to get the moles, that is just molarity times the volume. So ito yan. Again, convert nyo yung ml to liters. Convert them to liters. So yan. So once we are able to solve for the moles of this substance and that substance, ano susunod ng gagawin? I-convert sila into the product, which is silver carbonate, using stoichiometry, such as shown here. Okay, so from silver nitrate to silver carbonate, that is 2.5 times 10 raised to negative 3 moles. No? Yan yung mapoproduce. From sodium carbonate to silver carbonate, ang mapoproduce ay 4 times 10 raised to negative 3 moles ng product. So, kung sino yung pinakaonte sa dalawang product na mabubuo, siya ang theoretical yield. No? So that means silver nitrate is our limiting reagent. Sodium carbonate is the excess reagent. Okay? So ito yung gagamitin natin na yield, not this one. Okay? So the theoretical yield is this one, 2.5 times 10 raised to negative 3 moles. Then finally, since mass ang tinatanong sa problem, ang gagawin, you multiply the mole into the mass of your silver carbonate, and then the final answer is this one. Okay? So ganun lang, stoic pa rin yan. Last sem pa rin yan. So ano lang yung nadagdag sa atin this time? The use of molarity. No? So, yung molarity naman, that is just used to get the moles of your substances. Okay? So with that, tapos na yung ating lesson for today. Itong exercises, we will discuss them by Thursday. No? Di-discuss natin yan. And then, sabay-sabay yan sa sagutan. Together with the other questions sa worksheet na i-upload ko by Thursday then. Okay? So for now, just absorb the materials. Ito yung link sa virtual lab. Yan. Ito rin. Ayan din. Okay? So if you want to practice, just go there lang na sa mga links na yan. Explore nyo lang kasi ako ina-explore ko lang din yan. Okay? So that's all for today. Excuse me. Sir, ano po yung YouTube channel? Yung YouTube channel ko is yung J Chemi. Para sa mga hindi, nga pala yung iba sa inyo, wala last time na. Punta tayo sa YouTube. Punta tayo sa YouTube, then yung aking playlist. Ito ba yun? Ito na. Ito yung channel natin, JKemi. This is where I upload the course materials, no? So dito yung this semester, ito yon AY21 S2 class recordings. Ito yung ngayong SEM. So if you want to review your Anachem lessons before you take your quiz or your exam, punta kayo dito. Kung gusto niyo na mag-advance, punta kayo dito. Last year ko to eh. Okay. Pero kung gusto niyo mag-review ng last semester, especially yung stoichiometry, punta kayo dito. AY 2021 S1. Andito yung last sem. Puntahan niyo yung chapter 3. Hanapin ko lang. Hindi ko makita eh. Nasa kabilang screen yung etong double screen na to. Chapter 4 pala, sorry. Hanap lang kayo chapter 4 dito. Yung MT ha, medtech yan eh. Yung iba kong students dito, yun. Sila yung mga nandun. Kunwari ito, MT chapter 4. Alam ko day 2 ko yun na-discuss eh. Ito ata, check natin. Alam ko may mga taga section 8 dati dito. No? Makikita yung mga mukha nila dito. Ayan, so dito nga yung stoichiometry. Ayan, yan yung stoic part. No? So hanapin nyo, chapter 4, day 2. Kahit anong section doon, basta MT, medtech. No? So yun. So ganyan yung gagawin natin sa Thursday. No? So kung anong ginagawa ko dito, yun din. Ito yung mga iba nagre-recite sa akin. So ganyan. Mabagal yung globe eh. No? So yan. Yan, stoic. Basta ganyan, nood na lang kayo dyan just in case ha. So yan. Although, discuss pa rin natin siya sa Thursday na. Pero mas maganda na yung advance para bibukid tayo. Okay? So yan, yung link sa virtual lab, nandun na siya sa inyong lessons. Just open them. Bahala na kayo mag-exercise dyan kung ano gusto niyo gawin dito. Go. Kung gusto niyo matry yung pinagagawa kong halo-halo, pwede niyo gawin na. Okay, so yan lang. So let's make use of this virtual mga virtual labs, no? So yun lang. So anyway, do you have any questions about the lesson or okay na tayo? Okay na po tayo. Sige. So I'll see you again on Thursday. I will upload the worksheets by, let's say, around Wednesday. Pwede na kayo magsagot-sagot, no? Okay, pero kapag hindi ko siya upload ng Wednesday, edi Thursday ko talaga siya ma-upload na. So yun, next meeting, ang gagawin lang natin, magsasagot tayo ng questions, no? We'll clarify things, no? Para pagdating ng quiz next week, okay na kaya. Okay? So, by the way, this will be the last week of the adjustment period, no? So, please finalize your schedules if you're satisfied with what you're doing sa class natin na to. Edi you can stay, no? So, ganun lang. After this, wala nang atrasan. Okay? So, tuloy-tuloy na yung semester natin. So, yun. A copy of the class recording will be uploaded on YouTube, no, for reference or for review. And thank you for attending the class, no. Okay, so wala na ata kayong next class, no. So, please enjoy your day and stay safe always. Okay, I'll see you again on Thursday. Bye-bye po and ingat parate.